Hello and good evening to all of you. Am I audible? Am I audible to all of you? Hello, am I audible? Okay. Okay, so what we are going to do today is trying to understand some of the key concepts which you need to understand when we are studying in UPSC. We have to understand some of the key concepts which are involved in science and technology. So in science and technology, you would see that in UPSC in GS paper 3 syllabus, so you'll see that the keywords are mentioned. So with the keyword says space technology, the keyword says biotechnology, the keyword says nuclear technology, defense technology, IT and computers, robotics, but it doesn't say specifically about, let us say, concepts like force, motion, gravity. But when we study about space science and technology, in order to understand space science and technology, what is happening in space science and technology, you need to have a solid footing in the basic understanding of concepts like gravity, concepts like motion. So you need to know the different laws of motion. So when we study in space science and technology, you will come across that rockets, your whether your PSLV or GSLV, they work on Newton's third law of motion. So if you understand Newton's laws of motions, then you can understand what is the working mechanism of the rocket. Even aeroplanes, the jet engines that fly, that also works on Newton's third law of motion. So all the planets revolve around a sun. So the concept of gravity is involved. Why are planets revolving around sun? It is because of gravity. So concept of centripetal force, concept of centrifugal force is intrinsic when we are trying to understand space science and technology. So in this class, we will try to understand that uh, what are the things that are necessary for us to develop a holistic understanding of topics like space science and technology. So these topics are covered, some of the topics are covered in your NCERT. So from NCERT, we have picked up these chapters and we'll try to discuss and develop concepts of this, and we'll see the application also. Application as in the civil services syllabus, what is its use, why do we need to study about gravity for civil services also. So we'll see the application also. So in this, what we'll do, we'll look at the NCERT. So let us begin with this chapter. So let us begin with gravity itself, and then I'll like link it with your force and motion chapters also. So in gravity, so this chapter is taken from your NCERT. So I have opened the NCERT book only, and in this chapter we are talking about gravitation. So in gravitation, what do we need to understand? The very basic understanding is needed in even for solving or understanding the concepts involved in space science and technology. So why is Earth revolving around sun? Okay, what if the distance between the sun and Earth reduces, or if it increases, what is going to happen? What if Earth starts to spin faster, or what if Earth starts to spin slower? What is going to happen? So we'll try to understand these things by building the concept of gravity. So what do you understand by gravity? Yes, anybody, what do you understand by this concept of gravity? Yes. So when we are talking about gravity, see that what is relevant from exam point of view. So when we are talking about the gravity, what is gravity? Gravity, see, there are two conceptions of gravity, one which was given by Newton and one which was given by Einstein. So we'll try to understand the Newtonian concept of gravity. So when we are talking about gravity, we are saying that gravity is nothing but force of attraction. It is force of attraction between two bodies. It is a force of attraction between two bodies. The formula is not very important for you to know, but if you know, then it helps in solving some of the problems from civil services point of view also. So it is a force of attraction between two bodies. So if two bodies, they are having mass m1 and m2, then the force of gravity is, or a force of attraction between them is, the better would be to use a relation term m1 by m2 by r square. What does this mean? That heavier the masses, more they will attract towards each other, the longer the distance between them, so they will not attract each other. So this formula was used by Newton to explain the concept of gravity. Now this concept of gravity, if we take it to our planetary system, to the sun and our planets, how do you apply this concept? So in order to understand those concepts, you also need to understand this concept of circular motion. So let us just take, in the book the example is given that a boy is playing with a stone and he has tied the stone with a string. So this is, let us say, a stone, this is a stone, and this is the string, this is the string. And what this boy is doing is that he is circulating this stone. So he is rotating the stone, and what is happening, that when this stone is revolving, so his hand is creating a tension. This wire or this this thread is tight, this thread is tight. So there is a force which is pulling it towards the center. There is a force which is pulling it towards the center. This force is referred as the centripetal force. Centripetal force. So when you say centripetal, so it is center seeking force. Centripetal is center seeking force. So in this situation, the tension in the string is causing the rotation. Now what if the child starts to rotate the stone very quickly, or if he increases the speed of the stone, what is going to happen? So in such scenarios, what is going to happen is that there will be an outward force also. So in any circular motion, there are two forces that are involved. One is the center seeking force, that is called as the centripetal force, and there is an outward force which is called as the pseudo force, and this force is called as your centrifugal force. This force is called as your centrifugal force. So this outward force is not allowing this stone to fall at the center. So faster the stone is being revolved, so more the centrifugal force. If the centrifugal force increases to a large extent, if the centrifugal force increases to a large extent, then this string can break also. So that is the idea here. So that in any circular motion, there is something which is pulling the body towards the center, but why it is not falling towards the center? It is because there is a counter centrifugal force also. So can anybody give me an example of centrifugal force in daily life? Can anybody give me an example of centrifugal force in daily life? Yes. So even when we are washing clothes, what is happening? The dirt is dislodged with the detergent, but we want that the dirt should move away. So when the cloth is spinned, the dirt will experience a centrifugal force and it will move out. Even in milk, when we are trying to make, let us say, charge, so when we churn the milk, so we are using centrifugal force concept only. This concept of centrifugal force is used even in enrichment of uranium. So uranium, you will see that there are different uranium isotopes. So some is heavier, some is lighter. The heavier will experience more centrifugal force and it will move outward, while the lighter will remain at the center. So this concept of centrifugal force is utilized at many places. Now coming back, how do we apply this concept of gravity when we are talking about our solar system? So if we take this, if we take sun, so here is sun and here is earth. So what is happening that our earth, why do you think earth is rotating, or sorry, revolving around sun, and yet it is not falling on sun? Earth is revolving around sun because of gravity. So earth is revolving around sun because of gravity. So it is revolving around sun because of gravity, but it is not falling on sun. Why? It is not falling on sun because of the revolution. The earth is also experiencing an outward force, that is the centrifugal force, because this centrifugal force is countering the centripetal force. So in this case, the centripetal force is not the tension in the string, but rather it is the gravity. It is gravity. So the centripetal force in this scenario is gravity. So sun is pulling earth towards itself, but because of revolution of earth, a counter centrifugal force is produced, and because of that, earth is not falling on the center of sun. So it is in dynamic equilibrium because of the countering of centrifugal force with centripetal force. Now imagine if we take the situation of let us say a situation when we slow down earth, or what will happen if I increase the distance between sun and earth? Will the earth revolution speed, will it change or will it remain same? Okay, or let me put it another way. If I bring earth closer to sun, should earth revolve at the same speed or should it revolve at a different speed if we bring it closer to sun? Yes, anybody? So the question is that if we bring earth closer to sun, should it revolve faster or slower? Okay, so let me put this in a different context. So let us say if you have earth here, and at a distance of 400 kilometer you have this international space station. So this international space station, it is revolving around earth. This international space station is revolving around earth. Do you know that how many times does it circle the earth? How many times does it circle the earth? This international space station, it circles the earth 16 times a day. 16 times a day. If we increase the distance between earth and international space station, it will become slower and slower and slower. So when we are saying that if we bring earth closer to sun, if it has not to fall on sun, then it should revolve faster and faster. So what we are saying here, that in order to escape the gravitational pull of sun, earth will have to generate more centrifugal force. In order to generate more centrifugal force, it will have to revolve around sun at a faster pace. Okay, so this is the basic idea in the concept of like working of sun and earth. Now if we look further extend this concept of gravity, and there are many situations that are being asked in papers. So one of the favorite question making area is when we are on earth. So let us say when we are on earth, so let us say this is earth. So if a person is on earth, so earth is pulling a person towards the center of earth. So when earth is pulling to the person towards the center of earth, an individual experiences something. So we refer this as weight. Weight is nothing but mass into gravity. What is this gravity? This gravity is the acceleration due to gravity. So every object on earth is being pulled towards center of earth with an acceleration of g. So this value of g, we generally refer to it as 9.8 meters per second square. So this value of g we take as an average value, but this value of g is not same everywhere on earth. This value of g varies where we measure g. So if we measure g at the equator, if we measure g at the equator, and if we measure g at the poles, it is not the same value. It is not the same value. Why it is not the same value? So here the simple, just by using that formula, so force of gravity is proportional to mass of earth, mass of let us say an individual by the radius of earth square. So what we are saying that at the equator earth is not perfectly sphere. So the radius at the equator is different and the radius at the pole is different. At the equator the radius is more, so the force of gravity is less. So gravity here at equator is 9.8, but when we measure gravity at the poles, gravity is more. Why? Because the radius is less. If this value is less, so this force of gravity will be more. So this g is more at the poles. Adidev, yes, namaste. Okay, so now what if I ask you that what if earth starts to spin faster? The question is, if earth starts to spin faster, what is going to happen? If the earth starts to spin faster, what is going to happen? So we are saying that if earth starts to spin faster, will the weight remain same? Will your weight remain same? What we are saying that weight is what? Mass into g, that is acceleration due to gravity. What if earth, instead of spinning in 24 hours, it starts to spin faster and faster in less time? If it starts to spin on its axis in, let us say, just 1 hour, will we experience the same weight? Will we experience the same weight? Okay, Adi. So what we are saying, let us just revise what we have already said. So in any circular motion मतलब सेंटर में एक ऑब्जेक्ट है और यहाँ पे एक ऑब्जेक्ट है जो सन और अर्थ के रेस्पेक्ट में हम बात कर रहे हैं. सो इट इज़ इन अ सर्कुलर मोशन. सो इन अ सर्कुलर मोशन व्हाट इज़ हैपनिंग दैट this body is revolving around this body because of gravity. Because of gravity, earth is revolving around sun. But if gravity is pulling earth towards sun, why is earth not falling on sun? It is because of revolution around sun, a counter force is produced, that is centrifugal force. So if gravity is acting as a centripetal force, then the motion around sun is causing a centrifugal force. So in any circular motion, you will see this, that there is a centripetal force, and to counter that centripetal force, there is a centrifugal force. So what am I saying is that if Earth starts to spin faster, then what is going to happen, that you are going to experience more centrifugal force. You are going to experience more centrifugal force. So the gravity will be countered by the centrifugal force, and because of that, a person will experience what? Weightlessness also. It is said that if Earth starts to spin 16 times faster than the present speed, then a person will experience weightlessness even on Earth. Okay, so this is the understanding with respect to rotation. Now, what if we, in this case, what if we move away from Earth? What if we move away from Earth? Will we experience same weight, or will this weight change? If we move away from Earth, what will happen to weight? Will we experience same weight, or will we experience less weight? So because we are moving away from Earth, so this value, that is distance between the two objects, is increasing. So yes, so the weight will be less. Okay, so the value of G will be less. Okay, are you able to understand this? Similarly, if we take this sun and earth scenario, earth is revolving around sun. What if I bring earth closer to sun? Will it revolve around sun in 365 days, or will it revolve in lesser time? In lesser time or more time? Think from the perspective like Mercury. Do you think Mercury's revolution speed is faster than that of Earth? Mercury's revolution speed is faster. Why Mercury's revolution speed is faster? Because when it is closer to sun, it has to escape the gravitational pull of sun. In order to escape the gravitational pull of sun, only if it moves faster, it will produce a counter centrifugal force more, so that it is countering the gravitational pull of sun. Similarly, we can say that if when we move away from Earth, when we, let us say, talk about Neptune or Pluto, they are moving very slowly. Why? Because the gravitational pull, to counter the gravitational pull, the centrifugal force required is less. So are you able to understand this, that in a circular motion, so it is the force of gravity which is acting as the centripetal force. So centrifugal force counters the centripetal force. So this distance matters. So if distance is less, so we have to move faster. Similarly, when we talk about Earth and International Space Station, have you heard about International Space Station? International Space Station का नाम सुना है? India is also wanting to have its own space station. Do you know that how many times does the International Space Station circle the Earth in one day? How many times does the International Space Station? What is this International Space Station? International Space Station is a collaborative project of different space agencies, which is headed by NASA. So NASA, Canadian Space Agency, Russian Space Agency, European Space Agencies, they have come together and they have set up a satellite. This satellite is very big in nature. This satellite is habitable. It means astronauts can live in this International Space Station. And this International Space Station, it has been placed at an altitude of 400 kilometers from the surface of Earth. So International Space Station is at 400 kilometers from surface of Earth, and because it is said that it is very close to Earth, so it revolves Earth, or it circles the Earth in every 90 minutes. this International Space Station is circling the Earth in every 90 minutes. If it slows down, Earth will pull it towards itself, so it will fall on Earth. So if it has to escape the gravity of Earth, it has to revolve faster. That is why it is said that it revolves 16 times a day. If we increase this distance, yes, it is. See, moon takes how much time to revolve around Earth? Moon takes 28 days. This is taking just 90 minutes. Yes, it is revolving around Earth in just 90 minutes. Why? Because it is very close. Moon, is it revolving in 12 hours? No, Earth is spinning in 24. Earth on its axis is spinning in 24 hours. So 12 hours is day, 12 hours is night. So it is about sun and Earth. So when the part of Earth faces sun, that is the daytime. The part which is not facing the sun is night time. But moon, you would have heard that moon revolves around Earth in 28 days. But this International Space Station, moon is millions of kilometers away from Earth. So this International Space Station is just 400 kilometers from Earth. If I keep on increasing the distance between Earth and International Space Station, it will also slow down. Are you getting this idea? That because International Space Station is very close to Earth, so if it wants that it should not fall on Earth, it should revolve very quickly around Earth. Otherwise, Earth, because of its gravitational pull, it will pull the International Space Station towards itself. So it has to produce a good or substantial amount of centrifugal force. So only if it moves quickly around Earth will it produce a substantial centrifugal force, and then it will not fall, or it will keep revolving. In fact, the satellites, the low Earth satellites, so you would have heard about low Earth orbits, or you would have heard about Earth observation satellites. They are also revolving around Earth at a very fast pace. They would circle the Earth in just, let us say, 2 hours or 3 hours only. One complete revolution around Earth in just 2 to 3 hours. Are you able to understand this concept? So coming back to another concept, so let us try to understand this laws of motion. So have you heard about the laws of motion? See, from civil services point of view, you need to understand, just have a basic idea of the different laws of motion. So different laws of motion. So what are the different laws of motion? Who has given these laws of motion? Any law of motion that you can recollect? See, I know this topic becomes mechanical, but I will show you the application of this when we are doing space science and technology. When we are studying this in your UPSC, then this understanding helps in understanding the working of rockets like PSLV, GSLV. We'll see how. So laws of motion. So laws of motion was given by Newton. So the famous laws of motion, the first law of motion says that anything which is this law is also known as law of inertia. So if anything is in motion, then it will remain in motion, or if anything is not in motion, then it will try to maintain that state. So this is also the law of inertia. So it maintains that particular inertia. So how do we change that inertia? It is only by application of force. So if something is moving and we want to stop it, then we will have to apply force. If something is at rest position, if we want to move it, then we will have to apply force. So that is the first idea of law of motion. We'll see some examples little later. I want to reach to the third law of motion that has application in rockets, we'll see the first law of motion also again. Second law of motion actually defines what is force. So it says that force is nothing but mass into acceleration. So if a mass is at rest and if you are accelerating it, so from 0 to some speed, then you can calculate that what is the force. So you get a numerical value of the force. So first law talks just about inertia, and force can stop it or force can increase its speed. So the second law talks about the numerical value, or it gives the formula for force. What is the third law of motion? Newton's third law of motion. Newton's third law of motion says that every action has equal and opposite reaction. So this says that every action has equal and opposite reaction. Now, can you give any example of this? Every action has equal and opposite reaction. So in your NCERT, many examples are given. So let me just bring those examples. So this is not the chapter. Okay. See, in your NCERT, I'll mention that what are the things that you need to study, what are the things which you can leave or ignore. So So in third law of motion, here you can see this example of gun recoil. So what is this example? So it is saying that in a gun, when the bullet moves in one direction, when the bullet moves in, let us say in this direction, the gun will move in the backward direction. So the forward movement of the bullet is producing a counter movement on the gun. So this is an example of what Newton's third law of motion. In fact, everything around us follows this law. Even when you are walking, in this example that you are seeing, so here what is happening, that he is trying to push the boat, or he is trying to push the boat and he is trying to move or climb this one. So even when you are walking, what is happening, that you are pushing earth behind, but you are not able to push earth. Why? Because mass of earth is quite large, so earth is pushing you instead ahead. So even when you are walking, there is action of Newton third law of motion. Even when you are rowing means on a boat like this. So when you are using a paddle or when you are rowing it, so what is happening, you are pushing the water behind and that water is pushing the boat ahead. So this is the application of Newton's third law of motion. So where do we see its application in space science and technology? So let us see. So when we talk about rockets, so you would have heard about PSLV, GSLV. Have you heard about PSLV and GSLV? Adidev, have you heard about PSLV या GSLV सुना है? Yes. So what is the physics behind PSLV and GSLV? How is it able to move from Earth to space? Okay, so if I take a basic design of, let us say, your PSLV, so let us say its design is something like this, and it has some booster rockets also. So this is the basic design of your, let us say, PSLV. So what is happening that it produces a lot of gases. It produces a lot of gases. So you would have seen that there is a nozzle here and lot of gases come out from this. Lot of gases come out from this. So when lot of gases are coming out from this direction, the rocket is able to move in this direction. So here also we are seeing the application of what? Newton's third law of motion only. So here we are producing what? Hot exhaust gases. Here we are producing hot exhaust gases. Though those exhaust gases are moving out in one direction, so the rocket is moving in another direction. This is just to give you an example. Let us say if you take a balloon, and if you have tied the end, so when the balloon is filled with air, so you have filled the balloon with air. When you leave this end open, if you leave this end open, what will happen? What will happen when you leave this end open? So air will move in this direction. Air moves in this direction. Will the balloon remain static or will it move? Will the balloon move? If you have filled the balloon with air and you're leaving the end open, so will the balloon move or will it remain static? So what will happen is that since the air is moving in this direction, so the balloon will move in this direction. So in rockets also we are utilizing the same principle, that we are producing hot exhaust gases, and those exhaust gases, they are moving out in one direction and the rocket is moving in another direction. How do we produce these gases? Do you want to know how do we produce these gases in a rocket? So I'll just take some time to explain this, how it is produced. So in rocket, what you have, see, in order to produce hot exhaust gases, you need fuel. And you need something to burn the fuel. So you need oxidizer. So the design is such that you bring in the fuel from the fuel chamber, you bring in the oxidizer from the oxidizer chamber, and with the help of motors you bring in, and then you have these exhaust chamber. So what is happening here? the fuel is burned in presence of oxygen. When the fuel is, this is the combustion chamber. So this is the combustion chamber. This is the combustion chamber. So what is happening in combustion chamber, that the fuel is brought. I'll just change the color so that it is clear to you. So we are bringing in the fuel from here, and oxidizer or liquid oxygen from here, and this fuel is burnt in presence of oxygen, and this produces lot of hot exhaust gases, and these hot exhaust gases, they are passed out from the exhaust nozzle. So this exhaust nozzle is directing the hot exhaust gases in this direction. So these hot gases are moving in this direction, so the rocket is getting a thrust in this direction. So this is the major application of Newton's third law of motion in space science and technology, even in missiles. So this year in prelims there was a question on cruise missile, that is BrahMos a cruise missile or is BrahMos a ballistic missile? Do you know the difference between cruise missile and ballistic missile? So even missiles are also working on this principle only. Cruise missile is also working on this principle. Ballistic missiles are also working on this principle. In fact, even your commercial aeroplanes are working on Newton's third law of motion. Newton's third law of motion. So how do you think in aeroplanes are able to move? How do you think aeroplanes, or what is the mechanism of the jet engine? So jet engines are also just like balloons only. So what is happening in jet engine? So jet engine, if I say that jet engine is nothing but a balloon which is continuously being filled in with gases, and the gases are being released. So let us say this is a balloon and you are filled in with air, and this air is forced to move in this direction, or it is released from this nozzle, or it is released from this end. So when the air is moving in this direction, this balloon will move in this direction. Similarly in your jet planes also. So what is happening, that you would have seen that there are rotatory blades. So these rotatory blades, they are doing what? They are compressing the incoming air. So it compresses the incoming air, and then so there is something like this. And there is the fuel is sprayed. There is this fuel is sprayed, and this is the fuel spray. Fuel is sprayed, and then in air you have what? In air you have oxygen, and this oxygen will go and react with fuel, and this will produce a lot of hot exhaust gases. So when the fuel is burnt in presence of air and it produces hot exhaust gases, these gases are then made to move out in this direction. So even in your jet engines, that is in aeroplanes, what is happening is that air is being drawn in, air is it is helping to burn the fuel, and because of that a lot of hot exhaust gases are produced. These hot exhaust gases are passed out in this direction through exhaust nozzle. So if gases are moving in this direction, engine gets a thrust in this direction. So even in your jet planes, even in your commercial aeroplanes, we are using this Newton's third law of motion. Is this part clear to everybody? Are you able to understand this? So we have seen the application of Newton's third law of motion. Let us see what you can further read from this book. So we have seen Newton's third law of motion. See, in this book there are numericals that are given. That is not very important from exam point of view. You don't have to solve numericals in civil services, but you have to have a basic understanding of the different laws. So here in this example, here you can see that Newton's second law of motion is saying that. So here we are saying that the first law of motion can be mathematically stated from the mathematical expression for the second law of motion. So for the second law of motion, what is the law? So force is equal to mass into acceleration. So this is the second law. So second law of motion, so here it is mentioning action in our everyday life. So when this, what it is mentioning, that example of a cricket ball. So when a catcher catches a cricket ball, why does he draws his hand inside, or why does he pulls his hand towards his body? Why? Because if he stops the ball at that fixed point only, he will get injury or he will be injured. So to reduce that impact, so he pulls away his hand, or pulls the hand towards his body. So what is happening? Pulls the hands backward with moving ball. In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to 0. So what is he doing? that he is distributing the velocity. When he is distributing the velocity, the force that he will experience on his hand, it will be less, so he will be able to make a catch. So in high jump, so another example, it has mentioned that in high jump athletic event, the athletes are made to fall either on a cushion bed or on a sand bed. Why? This is to increase the time of the athlete's fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. So we are utilizing this concept in our daily lives also. So we are utilizing the concept, first law of motion, second law of motion, and the third law of motion in many areas. So we have seen many examples. So let us look at this in gravity. So we have mentioned, we have explained gravity. So in this book or in this chapter, what you can see is they have given the formula. So what it is saying, that force is inversely, so when we are talking about two objects which are separated at a distance of, let us say here the distance is referred as small d. So what is the force? What is the force of attraction between them, or what is the force of gravity between them? So here we have seen the formula, but the formula is not very important from exam point of view. What you need to understand in this formula, that it is saying that more is the masses, more they will pull towards each other. So in between, let us say if you take the example of sun and earth, so the mass of sun is much more than that of earth. So sun is pulling earth towards itself, at the same time earth is also pulling sun towards itself, but the force of gravity by earth on sun is very less, so it is not able to move sun. And it is also saying that it is inversely proportional to the distance between them. So more is the distance between the objects, less is the force of gravity. So that is the basic idea in gravity chapter. So what is this universal law of gravity? So Newton said that this law of gravity holds at every place, but this concept of gravity was challenged by Einstein. So if time permits, someday we'll also look at what is Einstein's conception of gravity. So Einstein conception of gravity, has anybody heard about and what is Einstein's conception of gravity? What is Einstein's conception of gravity? No? Okay. So here what we are saying, that there is a difference between concept of mass and weight. What we are saying, weight we are saying that earth attracts every object with a force, and this force depends on the mass of the object and the acceleration due to gravity. So weight of an object is a force with which it is attracted towards the earth. So what we are saying, that weight is not remaining constant. If we move towards, let us say, moon, or if we move towards other planet, so your weight will vary, but the mass will remain same. Mass remains same, but the weight changes. Weight is nothing but weight is given by mass into force of gravity. So we have seen this situation, that if we move towards towards the pole, then our weight tends to increase. Why? Because the gravity, the value of g tends to increase. Why? Because earth is not a perfect sphere, so at the poles the radius is less. If the radius is less, then the gravity is more, so weight tends to increase. Similarly at equator, the counter is true, that weight is less. What if we move away from earth? Now the question arises, what if we move inside earth? So in another scenario, let us say, so if this is earth, if this is earth, this is the center of earth, and let us say we are here. What if we move inside earth and we are at this point? what is going to happen to value of G? Will it increase or will it decrease? Yes, Adidev, think. What will happen to value of G? Will it increase? So we have said that when we move from equator to pole, the value of G is increasing. When we are moving away from Earth, value of G is, what is happening? G is, because radius is increasing, value of G is decreasing. When we are moving towards the center of the Earth, what will happen to value of G? Will it increase? Will it decrease? Yes, take a guess that whether it will increase or decrease. Okay, so let me explain what is going to happen. So value of G is proportional to what? Mass of Earth into, let us say, mass of the object, and the distance between Earth and the object. So we generally take this as R. R is the radius of Earth. When we are on the surface of Earth, we are taking this R. Okay, so what we are assuming, see, when we are taking Earth and object, or let us say ourselves, then we are assuming that the entire weight of Earth is present at this. We are assuming that the entire weight, mass of Earth is at this point, and this is mass of object, and the distance between them is R. Then only we are able to apply this formula. We are assuming that the mass of Earth is concentrated at the center of Earth. This concept is known as what? Center of gravity. Center of gravity. So the center of gravity, so we are assuming that the mass of Earth is present entirely at the center of Earth. So when we are here, then we are assuming that the mass of the Earth is, we have to take the complete mass of Earth. So we can apply this formula. So this will hold. Even this will hold when we are moving away from Earth. So when we are moving away from Earth, and let us say we have added delta R, so what is happening, that this R is increasing. Because this R is increasing, this G is decreasing. But can we apply the same logic when we are moving towards, or when we are moving inside Earth? When we are moving inside Earth, let us say you have entered a gold mine. Gold mines are generally deep mines. So if you move towards the center of the Earth, can you apply this formula? You will not be able to apply this formula, because this mass of Earth that you have taken is going to change. Why? Because when you are here, only this part of Earth is going to pull you towards the center. Only this part of Earth is going to pull you towards the center. So what is happening? This value, or this mass of Earth that you are taking, that is also reducing, and this R is also reducing. So here what dominates in this equation? So G is proportional to so we are saying G is proportional to mass of Earth by radius, square of the radius between them, or distance between them, and mass of the object. But this mass is also decreasing, and this is also decreasing. So what can you say about this, whether this will increase or whether this will decrease? Yes, what can you say? That when you are moving inside Earth, what will happen to the value of G? Will it increase? Will it decrease? So we have said that you cannot take the whole mass of Earth now. you cannot assume that the whole mass of earth is present at the center. You have to take the reduced mass. So if you look at the calculation, then in this equation what is going to happen, that this numerator dominates, and this value of g decreases. This value of g decreases. See, otherwise what you would have thought, that because this radius is decreasing, this g should have increased, because we are decreasing the distance between earth and the object, the value of g should have increased. But it is not happening in that way. It is happening counter to that. Are you able to understand this? That why the value of g is decreasing when we are moving closer towards earth. Is this clear to you, Adi? Okay, so in this equation, what is dominating? The numerator is dominating. The mass of the earth reduces drastically, so numerator dominates, so value of gravity is decreasing. So a simple mnemonic that you can make, that you can remember, is that whether you move away from earth, when you are moving away from earth, what is happening? When you are moving away from earth, what is happening to value of g? So g is decreasing. Why g is decreasing? Because you are increasing the distance between the object, between the center of the earth and between the object. So value of g is decreasing when you are moving towards center of earth, So that logic, that since the r is decreasing, so gravity should increase, doesn't hold. Here also we have said that gravity is decreasing. So the explanation here is different, that why gravity is decreasing. It is because the mass of earth is now lesser, so there is a lesser force of attraction between them, so the value of g is decreasing. So in both the scenarios, you can remember that whether you are moving away from earth or whether you are moving closer to earth, the value of g is going to decrease. Is it okay? So you should remember that when we are moving from the pole to the equator, then also value of g is going to decrease. What if we start to spin the earth faster? What if we start to spin? What if the earth starts to spin? It is said that if earth starts to spin 16 times faster than the present rate, 16 times faster than present rate, then what is going to happen? That we'll experience weightlessness. Why? Why do you think we will experience weightlessness if earth starts to spin faster? Earth now is spinning, let us, in 24 hours. So it is completing one rotation in 24 hours. We are saying that if it starts to spin 16 times faster than the present speed, we will experience weightlessness. Why do you think we are experiencing weightlessness? This I have explained, but I just want to see that whether you have understood this concept or not. Yes, so why do you think we will experience weightlessness? So the simple explanation is that if the earth starts to spin faster, it means we are also spinning faster. Because we will be spinning faster, the centrifugal force that we will be experiencing will be very high. So this centripetal force, that is the gravity, is same. This value of gravity will be same, but if it starts to spin faster, we will experience a counter centrifugal force, and that centrifugal force will counter this force of gravity, and we will experience weightlessness. That is the reason of weightlessness. So, in today's session, we have tried to see what is this concept of motion, what are the three laws of motion. We have seen some of the application areas. So, the most important application area is in space science and technology, in rockets and missiles, in your commercial aeroplanes. That is Newton's third law of motion is applied there. Then we have tried to understand the concept of gravity. So in that we have tried to understand what is this circular motion. In a circular motion you will experience two kinds of forces. One is the center seeking force, that is the centripetal force. So center seeking force is called as the centripetal force. So why is earth revolving around sun? Because sun is pulling earth towards its center. So the center seeking force in case of sun and earth is your gravity. So gravity is acting as the centripetal force, and because earth is revolving around sun, so that is producing centrifugal force. That centrifugal force is countering the centripetal force, and that is why earth is not falling on sun. So we have seen the different application areas of centrifugal forces also. So centrifugal force, the concept of centrifugal force is utilized in daily lives also, like in washing machine, like when you are making chach or when your mother makes chach. So we are utilizing that concept. When we are enriching uranium, then also we are using centrifugal force. So when you are driving a vehicle and when you take a sharp turn, then you tend to move away from the curvature. Why? Because of centrifugal force. So this concept of centripetal force and centrifugal force is important for you to know. So centripetal force and centrifugal force is we have seen some of the examples when the earth will rotate faster, then what is going to happen. So we have tried to understand that in some holistic manner. So tomorrow we'll try to cover other aspects of light and sound that we need to understand. So if you understand light and sound, some of the questions you can tackle, and that basic understanding is needed even in your UPSC. So in UPSC, in the several topics of space science and technology or in defense technology, you need to have some understanding of heat, light and sound. So we'll try to cover those things tomorrow. That is all for today. If there are any doubts, you can ask, or we'll close the session then. Any doubts for today? So if there are no doubts, we'll close the